Measures of central tendency and variation. So a measure of central tendency is a value that represents a typical or central entry of the data set. There are three main ones we use: mean, median, and mode. Now I'm just going to go through this. If you need to hit pause at any point, do so. I'm just going to move on. You should be aware of all these from Algebra 1 and Algebra 2 and so forth. So the mean. This is what most people in everyday life, when they say the word average, they're talking about the mean. Now all central tendencies are averages. Mean, median, and mode are all averages. But the one everyday people use in lay conversation, when they say, oh, my bowling average, my batting average, that is the mean. It's the sum of all the data divided by the number of entries. When you see it in your calculator, it's going to look like this. It's funky looking E, which is sigma notation, which means it added all the x values of the data. The population mean, which is this funky looking U, is the sum divided by n. That's how it looks. And then the sample mean, okay, also EX over N. Oops. Now, find the mean for the class height and data in inches. So what we're going to do is we're going to take our calculator, and we're actually going to use this data 3 times. So I'm going to show you how to do it on the calculator, remind you actually, because you should know how to do this. So we're going to hit our stat key. Now we're going to edit. Okay, I needed to get my L1 back. So we're going to put these numbers in L1. Now, if you're doing this at home, you don't have a calculator, but you can practice this in class. So we're just going to put the data in, 65, 62. I'm double checking as I go along. See if everyone's right. 68, 64, 61, 74, 68, 63, 64, 70, and 72. Now I should have 11 entries. Notice how it says L111. Now if I hit enter, it says 12. That's because I'm on the 12th entry, which has no number. If I go back up, that's my 11th number, so it matches up. Now to find the median, I'm going to run stat. Okay? And I'm looking for, the mean. So I'm going to do calc, and I'm going to do enter. I'm going to hit enter 3 more times, and there's my average right there. My average is 66.4545, so I'm going to round that to 66.5. Or not. All right? So that's the average. You could also just take your calculator and put all those in, add them up, and divide it by 11. But since we're going to be doing more things with these numbers, I have to put it in my stat portion of my calculator. Okay, the median. The median is the middle of the data. This is very important, especially if you're not using the calculator. You must put these in order. So look above. You can't look at this and go, oh, the middle one. That's going to be number 6. And say that's the median. It's not. 74 is not the median. In fact, that's the highest value. It can't be the middle value. They have to be rewritten in order first. Now, you divide it into 2 equal parts. If the data is odd, like this, 11 data points, then it's going to be the middle one. So, value number 6, 5 on the left, 5 on the right. If it's even, you take the mean, the average of the middle 2. All right? So, in this case, and I just really want to quickly show you, if you were doing this by hand, the first thing you would have to do is reorder these smallest to biggest. You want to be careful and make sure you got them all. And then you would count off 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and there's your middle value, 65. But since we put this on our calculator, we can just look right here. The median is right there at Q2. Well, Q2 is the same thing as the median. But it says in the calculator, median, 65. So, there you go. Now the mode is the one that occurs with the most frequency, the greatest frequency. It's the most often. If no entry is repeated, it has no mode. If 2 entries occur at the same frequency, greatest frequency, it's bimodal. It can also be trimodal, okay? Or, keep going. You can have more than one mode. Now this one, the calculator does not show us, okay? And you could just look through and find which one has more, but it is easier if you have them in order. Now we wrote it above, you could just use that list, but I'm just rewriting it again real quick. The mode kind of pops out if you put them in order because then the numbers are grouped together. And it's just easier to find, especially when you have more than one mode. So if you look here, there's 2 of these and 2 of these. That's more than everything else. So that's 64 and 68. It's bimodal. Think about a bicycle, 2 wheels. Okay? So bimodal, 2 modes. All right. This was taken, and there were 34, 56, 21, and 9. What's the mode? There is none. No number occurs more often than anything else. So we just say no mode. All right. So, comparing the mean, median, and mode. All 3 measures describe a typical entry of a data set. The advantage of using the mean, it's more reliable because it takes in every entry into account. The disadvantage of using the mean is it's greatly affected by the outliers. Okay? So if there's a number that is way bigger or way smaller than most of the data, that will throw off your mean. We talked about it in class before. If everybody does really well on a test, but then someone got 30%, that's going to drop the class average. Okay? If the class did poorly, but one person got 100% on the test, that's going to raise the class average. But the class average is not going to be an accurate representation because of that outlier. So let's look at this. We're going to compare the mean, median, and mode. And see which one would be best, and are there any outliers. Well, you can kind of look at it right now and say, whoop, that one dude is really old compared to everybody else in the class. Okay, you just see that it pops out. But we're going to do the math on it anyway. So we're going to look for the mean. The board will cooperate. Maybe it won't. The median and the mode. So we're going to pull up our handy calculator. Go to Stat, Edit. Now, a quick way to get rid of these numbers is go up to L1 and hit Clear, not Delete. That will get rid of your column and come back down. Now I'm going to put these in. There are 6 20s. 1, 2, 3, 4, 5, 6. 6 20s, yep. And then there's 4 21s. 1, 2, 3, 4. 1, 2, 3, 4. There you go. And then there's 3 22s. 1, 2. And you got to be very careful when you're entering data. There's 4 23s. 1, 2, 3, 4. And then there's 2 24s. And there's 65. They should have 20, and that's number 20. Okay? So then we go back to Stat, over to Calculate, enter, enter, enter. Okay, the mean is 23.75. The median The middle value is 21.5. And the mode is 20, because there are 6 of these. Next to the number is 21, 23 with 4 values. Okay, 65 is an outlier. And so the more accurate representation is the median, due to the outlier. Because that 65 raises the average, okay, to 23.75, which is the upper end of most of the ages, right? If you look at it, you got 65, 24 is not, you know, the average, it's a high end. So let's go back, just for the heck of it, let's go back to our data and see what happens. Let's go down and take out that 65. Whoops. Ready to do that. So 65, I want to delete that entry. Now I want to run my stats and see what the average is. Look at that, 21.57. So when you take the 65 out, now what's the new median? 21. So the median doesn't change much, but the average comes down way closer to that. So good to know. All right, the shape of a distribution. Symmetric. Symmetric means the left side matches the right side. So if you have this line down the middle where the mean, median, and mode are all equal, and you have this perfect bell curve, that's symmetric. And it doesn't have to be a perfect symmetric, you know, to have a symmetrical shape, but this would be a representation that is perfectly symmetrical. Now, uniform, it looks like a box. It's a rectangular box. All the entries or classes have the equal or approximately equal representation, frequencies. So here, the median and the mean are the same. But there's no mode because everything's exactly the same. So there's no clear leader. Then we have our skew. We talked about this before, the tail of the whale. Okay? If it's skewed left, so if you look at this, most of your data is on the right side. Here. Okay? And there's some low entries pulling down the average left of the median. And it's going to pull that average down so it skews negatively left. On this one, most of our data is right here. We have some positive data pulling the average up. It's right of the median. It's increasing the average. And therefore it is skewed right. Come on. All right. The range. You've been doing this for years. The range is the difference between the maximum and the minimum. Biggest minus the smallest. The data must be quantitative. You cannot subtract red from yellow or dogs from horses if you did a qualitative what's your favorite animal. It has to be numbers. The biggest one minus the smallest one. Now, deviation, variance, and standard deviation. Deviation is the difference between the data entry and the mean. Okay? Population data set, if you look at the population, the deviation of x is x minus that funky u we talked about. And the sample data set is x minus x bar, which is the average. Find your deviation from the mean. What does this number indicate? So here are all the actual formulas for how to do it by hand. But we are going to find the sample standard deviation with our calculator. Okay? So we're going to go back to our original data. I need to re-enter again real quick. We moved on to the next problem. So real quickly, I'm going to enter these numbers in again. So 65, 62, 68, 64, 61, 74, 68, 63, 64, 70, and 72. Thinking we should have 11? We do. Good. So we hit stat, we run calculate, enter a bunch of times, and now we have two standard deviations, XX, okay, and sigma X, that funky looking O. So we have 4.25 and 4.05. We have SX and that funky sigma. Alright? Now, this is our sample population deviation. So this is what we're looking at right here, 4.25. And that's it.